Okay, this time I'm going to explain the homework problems from section 8.3 of calculus, which is about trig integrations. First one is just a review from derivatives. So let's say y is equal to ln of x squared. So derivative of the log is what? So derivative of the log ln of u, derivative of like this is equal to 1 over u times u dash by the chain rule, which is u dash over u. So dy dx is equal to x squared on the denominator and that derivative on the top. So the answer is 2 over x. Okay, next one is the integral of the product of cosines and sines. So cosine x cubed times sine x dx. The good thing is this one is have only a single sign here and the rest is a cosine. コサインの式かけるサイン1個分なので、これは let u is equal to cosine x dx. Then du, sorry, cosine, just cosine x. Then du is negative sine x dx. So after the substitution, you want to get integral of u cubed times this, which is negative du. So du times negative 1. Using a power rule to integrate u cubed to get u to the power of 4th. And we turned it to x. So u is equal to cosine x. So get back to x. So cosine x to the power of 4th plus c. Next one is a cube of cosine only. So no sine is included. So 5 times cosine cube of 2x dx. Good thing is, well, first thing to check is whether this is odd or even. And because this is odd, you can just break one of them apart. Well, 5 is just a scalar product, so put outside of the integral. So first thing to do is split into single term, single cosine, and the rest. Okay, if this is odd, then you can get 1 out and you're gonna get even power here. Now, using the Pythagorean theorem, cosine square become 1 minus sine square. Now, just like a previous problem, you have a function of sine and the derivative of sine here. Okay, so let's say u is equal to sine 2x. Then du is equal to cosine 2x dx times the product of derivative of the inside, which is 2. So after the substitution, it's going to be 5 integral of 1 minus u squared times this part will be 1/2 du, 1/2 du. Okay, so 1/2 is out, 1/2 is out. So integrating this, you want to get u minus 1/3 u cubed. Bring back to sine, it's going to be 5 over 2 sine 2x minus 5 over 6 times sine 2x cubed. Don't forget to add constant. Okay. Now next one is kind of ugly. It's a definite integral. 0 through pi over 12 sine to the power 5 of 6x dx. Well, I really don't want to work with 6x first. So let's just make a simple substitution. T is equal to 6x. Then dt is equal to 6 dx. And you have to change the interval. So when x is 0, t is 0. When x is pi over 12, t is pi over 2. After making a simple substitution, it's going to be sine t to the power of 5 times 1 over 6 dt. 1 over 6 is just a constant, so you can put it outside. So the program becomes this. Now, notice that this is just the power of 5, which is odd. So we can apply the same technique as we do in the previous program, which is leave 1 out. Okay, so evens and 1 out. Rewrite this one in terms of cosine. Rewrite this one in terms of cosine. So sine square is 1 minus cosine square. And because we have square squared, it's going to be square of this one, okay? Okay, now you have a function of cosine t, and its derivative is here. So let's say, let u is equal to cosine t. Then du is equal to minus sine t dt. Because this is a definite integral, you can just change it to u value. So when t is 0, u is 1. And when t is pi over 2, cosine pi over 2 is 0. So it's going to be 1 over 6, 1 through 0, 1 minus u square times minus dt, minus du. Okay, because this is minus du. Okay, let's put this negative to change this number, change the order. What it means is, just to make this computation a bit easier, what I just used is integral of a through b of f is equal to integral of the negative f b to a. Okay, so I can flip the order. Now expand this one and integrate. So expand it and integrate. It's going to be u minus 2/3 u cubed plus 1/5 u to the 5th, 0 through 1. So it's going to be 1/6 of 1 minus 2/3 plus 1/5 minus 0, 0, 0. So it's going to be 8 over 90, which is 4 over 45. So it's going to be 4 over 45. Okay. Looks more formidable. Number 5. So integral 6 is not important. So 6 times sine cube 4x times cosine 4x cube. Both of them is odd, so we can use either one. Let's split cosine. So make cosine square 4x times 1 out, like this. Okay, 1 out. And rewrite this one in terms of sine. Oops. So it's going to be sine to the 3 4x times 1 minus sine square 4x times cosine 4x dx. So now you have a function in terms of sine 4x and its derivative is here. So let's say u is equal to sine 4x. Then du will be cosine 4x dx times 4. After making a substitute, you want to be u cube 1 minus u square 1/4 du. So 1/4 can put out, so 6/4 becomes 3/2 integral of u cube minus u fifth. So integrated, it's going to be 1/4 u to the 4th minus 1/6 u to the 6th plus c, which is simplifies to 3/8. It's going to be sine 4x minus 1/4 sine to the power of 6 of 4x plus c. Okay, so it's going to be 3/8 sine to the 4th of 4x minus 1/4 sine to the power of 6 4x plus c. Okay, number 6. Now you have an even power. So 2 times cosine square of x dx. Well, now this one is even, so we really need to use a different technique. When you have evens, you will use the following half-angle identity to rewrite the expression like this. So cosine square of x is 1 plus cosine of 2x over 2. Sine square x is equal to 1 minus cosine 2x over 2. Okay, so let's use this formula to simplify this. So after you do that, it's going to be 2 times 1 plus cosine 2x over 2. Now power is decreased to a single power here. Now you can integrate it. It's going to be x plus sine 2x divided by 2 by chain rule plus c. Okay, next one is, again, number 7 is 13 integral of 13 sine square x cosine square x dx. So now you have both of them even. So we are going to use this formula to simplify. So 13 is just a numerical constant, so you can put it outside. Sine square is 1 minus cosine 2x. Cosine square is 1 plus cosine 2x divided by 2. Let's put this numerical constant product out and expand this one. You want to get 1 minus cosine square of 2x. This is integrable. We know how to integrate this. This one, you still have even power. So you have to use half-angle identity again. So it's going to be 1 plus cosine of the double angle. So twice of 2x, which is 4x here. So combine like terms, 1 minus 1/2 minus 1/2 cosine 4x. Okay, so now you can integrate both of them. So first term will be 13 over 8x. And the second term is 13 over 8 times sine 4x. But chain rule gives you another 1/4 here. Okay, now you have a power of 6 and power of 3. Number 8. So now you have a mixture of even and odd, but if one of them is odd, use this. So this is odd one. So we can use this part to break down into single power and the double power. 63 is okay. We can leave it outside. This one become cosine square become this, and one cosine remains here. Okay, now you have a expression in terms of sine multiplied by the derivative of sine. So let u is equal to sine x, du is equal to cosine x dx. So this is definite integral. So we have to change these two numbers. So when x is pi, sine pi is 0, and sine 3 pi over 2 is -1. So 0 through -1, it's going to be u to the power of 6, 1 minus u square, and this everything becomes du. Okay, now integrated, it's going to be 1/7 u to the 7 minus 1/9 u to the 9th, and you plug in -1 and 0. Plug in -1, you're going to get -1/7 plus 1/9, and plug in 0 gives you 0. So the answer is 63 -2 times 63, so it's going to be -2. Oops. So the answer is -2. Okay, now next type of problem, which is removing a square root by using a double angle, half angle identity. So now the problem is a type of the square root of 1 plus cosine or 1 minus cosine, that kind of question. Okay, we are going to eliminate the square root sign by rewriting this one into squared form. How we do this? Well, cosine square of x is equal to 1 plus cosine 2x over 2. So 1 plus cosine 2x is equal to 2 times cosine square x. That's what we are going to use. So this is becoming 0 through pi over 6. 12 can be put out. So inside it becomes 2 times cosine square of, instead of 2x, you have 6x here. So it's going to be 2 times 3x should be used instead. So here going to be 3x. Yeah, we are using half angle identity. So square root of 2 can put outside. And the square root of the square become an absolute value of inside. Okay, remember square root of a square is equal to a absolute value. Now we can eliminate this absolute value because when x is less between 0 through pi over 6, as in this problem, 3x is between pi over 2, sambai, through 0. So all the angle here is used here is first quadrant angle. So cosine of that one should be positive. ということで、場合分けの必要は今回はなく、絶対値記号をそのまま外せますと。Now you integrate it, you're gonna get the 4 square root of 2 sine 3x and 0 through pi over 6. So that's gonna be sine pi over 2 minus sine 0, which is 1 minus 0. So the answer is 4 square root of 2. Okay. Next one, number 10. Integral of kind of complicated expression, sine to the power of 4 of x over square root of 1 minus cosine x dx. So let's use the same technique. We might have to use half angle identity to eliminate this square root. But the problem is the angle will change. Angle will be halved. So that might give us kind of hard time. But let's try to do. So sine square of x is equal to 1 minus cosine 2x over 2. So this one can be written as 2 times sine square x. Now hard part is because this is 2x here. Now if this become x, this is gonna become half of that angle. So it's become pi over 3, pi over 2. Sine to the 4th power of x over square root of 2 times sine of half angle square dx. Notice that in these two, when x is between pi over 2 through pi over 3, x over 2 is between pi over 4 and pi over 6. So this is positive. So we can just remove absolute value sine. So you want to get sine x over 2 and sine cos x dx. Okay. Now we really don't like although we have two same functions, it's not really nice because the inside angle is different. So let's use some technique to solve this. So sine of the double angle identity is this. Okay, so I'm gonna use this one to rewrite the angle here to match with this. Okay. So it's gonna be kind of complicated. So this is same thing as 2 times sine x over 2 cosine x over 2. So that's gonna be sine of, you know, what I do is sine of 2 times half of x is equal to 2 sine x over 2 times cosine x over 2. That's what I'm doing. So I had to do some kind of substitution here. So that's half double angle identity to the power of 4th divided by sine x over 2 dx. So 2 to the 4th is going to be 16, and 16 can be put outside because it's a numerical constant. The sine to the power of 4th canceling with the bottom one, so it's going to be like this. And you still have cosine to the 4th power here. Now you reduce the problem into something we have done previously. So looking at the power here, you see odd here. So let's rewrite the cube into doubles and the single term out. So single one out, and you have square left and change it to cosine square. Okay, now you have an equation in terms of cosine x over 2 times its derivative here. So let u is equal to cosine x over 2. So du will become negative sine x over 2 dx times 1/2. We are going to change interval. So when we plug in pi over 2, it's going to be 1 over square root of 2. When you plug in pi over 3, it's going to be 2分のルート3なんで、分のルート3。はい。ルート3。はい。So it's going to be 16 over square root of 2. 2分のスクエアルート of 3. 2分のスクエアルート of 2. It's going to become 1 minus u square u to the 4th. This will become minus 2 du. Minus 2 du. It's a long computation. Okay. Let's put negative 2 outside. It's going to be u to the 4th minus u to the 6th, which is terrible. Okay, so after integrate this, you're going to get 1/5 u to the 5th minus 1/7 u to the 7th, and you're going to plug in these numbers. Okay, that's going to be kind of ugly. Let's put u to the 5 out. So it's kind of make a bit easier, I believe. So it's gonna be, this is 1 over square root of 2. So it's gonna be 1 over square root of 32. 1 over 5 minus 1 over 7 times 1/2. Wow. And this is gonna be 9 square root of 3 over 32. Yeah, I should do that. I should do that. 上5乗下5乗で、4ルート2オーバー32にしとこう。And this is going to be 1/5 minus 1/7 times square of this. So it's going to be 3/4. Wow. Hope this become easy. Multiply this part out. Let's use distribution. It's going to become negative 4 times 1/5 minus 1/14. Plus, it's going to be 9 square root of 3 over square root of 2 times 1/5 minus 3 over 28. It's going to be 70, 14, 5, 9. And that is going to be 10, 9 square root of 6 minus 28 square root of 2, 27 square root of 3. So the answer is negative 18 over 35 plus 9 square root of 6 over 10 minus 56, 27 square root of 6. So I can combine these like terms. It's going to be 280. 28倍なんで、I should put 9 out. ですね。Let's put 9 over 2 out. It's going to be 5 and square root 6 out. So it's going to be 1/5 minus 28, 3. So that's going to be 140, 28 minus 15, 13. So 117か。117 square root of 6. So kind of messy here, but the answer is negative 18 over 35 plus 117 over 280 square root of 6. That was wrong. It's going to be like this. Okay. Now problem about the tangent and secant. So number 11. So it's a tangent times secant square x dx. Remember, the derivative of tangent was secant square. So this can be considered as a function in terms of tangent multiplied by derivative of tangent. So let u is equal to tangent. Then du is equal to secant square x dx. So after the substitution, it's going to be u times du, which is 1/2 u squared plus c, and that's you want to get this result. Number 12. Now you have lots of powers of secant and tangent here. Now another formula you have to memorize is the derivative of the secant was secant times tangent. So now you can split this one into secant times secant tangent. Okay. シーカントとそれの微分の形に分けると。Now, so let u is equal to secant 4x. Then du is equal to secant tangent times 4 dx. So after substituting, it's going to be u to the power of 6 times 1/4 du. So the answer is 1/28 u to the 7 plus c, and bring back u to secant, like this, okay? Next one, you have 2 secants and 2 tangent. What should we do with this? Well, this is same as a problem number 11. You have a tangent and the derivative of tangent here. Okay, so tangent の式かけるその微分があるので、well, this is simple. So let u is equal to tangent 6x. Then du is secant square 6x dx times 6. So after substituting, you want to get u square du divided by 6. After integrating it, you're going to get u cubed divided by 3, and you bring back into tangent x. Okay. Number 14. So now I have 20 secant to the 4th tangent square d theta. Now, what should we do when you have 4 secants instead of 2? Well, we are going to use the Pythagorean theorem to convert one of the secant squares into tangent. So 20 can put out. Secant square can be split into secant square and secant square. Okay? 4乗をですね、2乗と2乗に分けます。And you can rewrite this one in terms of tangent. So this will be a function in terms of tangent, and this is the derivative of the tangent. ということで、タンジェントで表された式かけるタンジェントの微分という形にできます。So u is equal to tangent, du is equal to secant square theta d theta. So after u substitution, it's going to be u squared plus 1, u squared du. Then after integrated, you want to get u の5乗 1/5 plus u cubed 1/3 plus c. So it's going to be 4 tangent fifths and 20/3 tangent cube plus c. Did I miss something? これ20割る5はちょっとダメですよね。これ4に直せよって感じですけどね。And oh, of course, I missed it. It's not x, but it's theta. Good. Okay, next one is secant to the power fourth. Number 15. 16 times secant to the power fourth of 6 theta. Okay, let's rewrite this one into secant square 6 theta times secant square 6 theta as we did it in the previous program. So again, we want to split the power 4 into 2 and the remaining. 2とね、その他に分けます。And this one can be written in terms of tangent, like this. So this is an equation in terms of tangent, function in terms of tangent, and this is a derivative of tangent. So exactly same technique works. So u is equal to tangent 6 theta. So du is equal to secant square 6 theta d theta times 6 by the chain rule. So after the substitution, it's going to be 1 plus u square, that's the main part. And this is going to become du divided by 6. du だね。So integrate each piece. Let's put 6 outside. Integrate this one, you want to get u plus u cube over 3 and plus c. Now return to theta, it's going to be like this. 8 over 9 tangent 6 theta cube and plus c. Type it. So tangent cube 6 theta c. Okay, number 16. How about if we have 3 tangents? So 18 times tangent x cubed. Okay, so when you have 3 tangent, let's put 1 tangent out. So you have 2 tangent and 1 tangent. And rewrite this one in terms of secant. Like this. Okay. This is not so simple, but when you split into 2 pieces, we might be able to solve. Okay. This piece is something we have done in previous questions, which is the function in terms of tangent times its derivative. ね、タンジェントの式かけるその微分の形になっているんで、これは積分できます。置き換えで。The integral of tangent is something you might want to memorize how to do. Rewrite tangent into sine and cosine. And the derivative of the denominator is a numerator type. So you can integrate using log. Okay. So after you deal with the u substitution, this part, you want to get 1/2 tangent x squared. For this part, because the derivative of the bottom is equal to top, so it's going to be ln of the absolute value of the denominator. So that's going to become 18 times ln of absolute value of cosine x. Okay, now cotangent cube. Well, honestly speaking, we really don't like cotangent and cosecant, but how we deal with this is similar to how we deal with secant and tangent. So this problem is very similar to tangent cube. Tangent cube. So have we solved the tangent cube problem before? Yes, we just did it previously. So we are going to use basically the same idea as we did it in the previous problem. So first of all, split this one into square and a single term. And rewrite this one into cosecant. So just like 1 plus tangent square is equal to secant square, 1 plus cotangent square is equal to cosecant square. This is gonna be the one we are going to use. So this is cosecant square 2x, 2x minus 1 times cotangent 2x dx. So this is going to become cosecant square of 2x times cotangent 2x dx minus the second part will be just a cotangent 2x dx. Oh, sorry. Okay, so derivative of this one become this. So let's use the u substitution here. So let's say u is equal to cotangent 2x. Then du will be just like a tangent derivative is secant square. Cotangent derivative is cosecant square 2x dx times 2. But it's going to become negative for this one. Okay. Well, after the substitution, so when it's going to be pi over 6, it's going to be cotangent of pi over 3, which is 1 over square root of 3. And this gives cotangent of pi over 6, which is square root of 3. It's a reciprocal of tangent. So that part will become square root of 3 through 1 over square root of 3 of u times this. This is du part, du divided by minus 2. After integrating it, it's going to be negative 1 over 4 u squared. And you're going to plug in this. Let's put 1/4 out. So it's going to be square here. It's going to be 1/3 minus u squared in square root of 3 squared. It's going to be 3. So that part is 3分の8、3分の2ですかね。3分の2になります。This part is same thing as cosine 2x over sine 2x. So derivative of the denominator is basically numerator with just missing 2. So let's multiply top and bottom by 2, like this. So derivative of the denominator is numerator. So its integral is negative 1/2 ln of the denominator. Okay, now plug in these values. So it's going to be negative 1/2 times ln of sine pi over 3 minus ln of sine pi over 6. So ln of pi over 3, it's ln of 2 square root of 3 minus ln of 1/2, which can be simplified to ln of square root of 3. Okay. So what I just used is ln of a minus ln of b is equal to ln of a over b. Okay. Also, this is power of 1/2, so I can put it outside of ln, so I can simplify it to something like this. Okay. So it's 2/3 minus 1/4 and then OC. Okay, 2 more problems. Now you have a sine times cosine, but the inside angle is different. When you see something like this, what you can use is a product to sum formula. In Japanese, it's a 積和公式. The product to sum formula is derived from some identities or difference identity. サイタコスモスなんちゃらってやつですけども、サインかけるコサインなんで、サインの加法定理2つ縦に並べて書きます。So this is going to be サイタコスモス、コスモスサイタ。And the bottom one is also same, but the sign flip is like this. Okay, when you add these two, the latter term is canceling each other. So you're going to get 2 times sine A times cosine B is equal to sine of A plus B plus sine of A minus B. So this product can be written as a sum. So using a formula, 2 came down, so it's going to be 1/2 times integral of sine of the sum A plus B, which is 25x, plus sine of the difference of the angles, which is 7x. Okay, so after you integrate this, it's going to be 1/25 cosine of this, and 1/7, 7 came, cosine 7x plus c. So it's going to be minus 1/50 cosine of 25x minus 1/14 cosine of 7x plus c. Okay, last one is a cosine times cosine. So again, you can use sum to product formula for cosine version. So you're going to use the cosine additive identity. So cosine A plus B is cosmos minus saita saita. And this one is cosmos plus saita saita になります。When you add these two, you're going to get cos. If you subtract one from another, you get sine. In this case, you want to get cosine times cosine. So we want to keep this, we want to eliminate this. So you are going to take a sum. Okay, so divided by 2, you're going to get this. So after rewriting the expression, it's going to be 1/2 times integral of cosine of 35x plus cosine of 5x. So both of them is easily integrable. So it's going to be 1/70 sine 35x plus 1/10 sine 5x plus c. Okay. So it's going to be like that. But there's another way to solve this one, which is something I'm not going to recommend much. But here's how. From section 8.2 in previous section, we have learned integration by parts. So look at this as a product of two functions. So let's say one of them is f, another one is g dash. Then let's use integration by parts technique. So this is cosine of 20x, and this is cosine of 15x. So differentiate twice, you want to get negative 20 sine 20x. Differentiate again, you want to get negative 400 cosine 20x. Integrate, you're going to get 1/15 sine 15x. Integrate again, you're going to get negative 1/225 cosine 15x. And plus minus plus. Do you see like this become this plus this plus integral of this one where you see the original expression appears. So using the table, let's say this is I. So I become 1 over 15 sine 15x cosine 20x, which is this piece. And the second term is minus times minus times minus, which is minus 20 over 225 sine 20x cosine 15x. And plus minus plus, plus minus minus, so that's going to be plus integral of 400 over 225 cosine 20x cosine 15x dx, which is I. So I is equal to 1 over 15 sine 15x cosine 20x minus, I'll just leave it as it is, plus 400 over 225 I. Bring this one to the other side to combine like terms. It's going to be negative 175 over 225 I is equal to this thing. So I is equal to 225 over 175 of this function. So sine 15x cosine 20x minus 20 over 225 sine 20x cosine 15x. So after reduce the fraction like this, it's gonna be 15 over minus 175 of S15x C20x plus 20 over 175 sine 20x cosine 15x, and to add C. So let's see the Pearson accept this answer. So it's gonna be negative 3 over 35 sine 15x cosine 20x plus 4 over 35 sine 20x cosine 15x plus C. Okay, so Pearson accept this answer, but I recommend you to just be able to apply the sum to product formula, because that's much easier to do, as you see here. Okay, that's it for today.